friends, it's STEAM week, and today we are going to talk about ramps. Ramps cover math and science and technology and engineering. To make ramps, we need some kind of height. So something like a box or a basket, or you can use maybe the edge of a low counter. Depends on what size of cardboard or board you have that you can use also. So you can open up a box, an empty box, and you can make a ramp out of that. Or you can use a piece of board, a piece of plywood, or just like a 2x4 you can use as a ramp. Depends on how big of things you want to roll down it. So if I might need a bigger board or bigger piece of cardboard if I wanted to do this. Rather, if I'm just using this, I can use, this is a small card. I can use something smaller. So first we're going to construct our ramp. So I have a bigger box, and I can put it like this, or I could put it like this, right? But I'm going to put it like this for now. And then I have a smaller box. It's lower to the ground. It's not as high. And then I have a basket. And you can use all different kinds of things. Like if this was longer, I could do that. But if I use this as my ramp, my things would nosedive right at the bottom. But because it's steeper, it would probably go quite fast. This, I can make work up there, but it's kind of bendy. So I went like this maybe. Oh, it's not quite tall enough to go up there. So what I'm going to do, I'm going to construct my ramps. So I'm going to maybe try this one right here. Let's see, maybe this will go better. Yeah, just play with it however you want. That looks like that might work. And then this is a littler one, so I'm going to put this one over here. I'm doing it that way because it has a nicer slope at the bottom. The slope at the bottom makes it, if I'm using a car, it's able to go down smoother and not nosedive at the bottom. Nosedive, it goes like, sometimes they stop because it's too steep. So first we're going to talk about, Miss Patty's going to use a yellow ball. We're going to talk about force and motion. Okay, so if I put this ball right there and there's no force pushing on it, it doesn't move, right? So to move, an item needs force to make it move, to create motion, okay? So I can use my hand to push it. Maybe since this is a really light ball, if I blew on it, if I blow on it, I could create force. That's the air blowing on it, and that makes it move. So what should we try? Miss Patty's going to take her hand, and I'm just going to barely push it. See what happens. Whoa! Did you see that? That was enough force on the ball to make it move. And the more force, the faster it will move. So I'm going to go, whoo! And the farther it will move. So that one the first ball, I just touched with my finger, pushed it with my finger, and it went right near where the computer is, the laptop. But the other ball that I pushed with my hand harder, it went further because it had more force behind it. It made it go farther. And then we have, if we make a ramp steeper, it might go faster also. Do we have one more? I had 3 balls, but 3 yellow balls, but I think I missed one, but that's okay. So that's something to try at home. If you make steeper ramps, they might go further, but they might not because they might stop at the bottom. If it's a steep ramp with maybe a little bend to let it keep going, it probably would go further. So, but then what if that ball was round and smooth? But what if I try to use this cube and it's not smooth and it's not round? So let's see what happens if I put it on here. Now this, if I let it go, it will probably move because it's on the slant and gravity will be pulling it down, and it's slippery. The gravity will be pulling it down also. Ready? Wow, it didn't really roll much and it didn't go very far or very fast compared to if I put a ball on it, or even if a ball like this is still round, it has texture on it. Like this has different textures on it. But if we take a ball and a square, and I'm just going to let them go, let's see which one's going to go down faster and easier. The ball went much further. Then I have this. This is a shaker toy. It makes noise inside of it. If I put it right there, it's not going to go anywhere unless I push it. And if I put it like this, it's going to roll to the side, but it's not going to go down my ramp very well, is it? It's going to roll to the side. Let's see what this one does. I'm going to have to push it to make it go down, and it doesn't go down very well. But what if we experiment and we try to put it on its side like this, because now look, it has this rounded edge to it, these rounded edges. See what happens. And I just need to give it a little bit over the edge, and wow, it rolled way over there. Sorry you didn't get to see that as well. I'm going to try to push it back here and then you can see it. We'll try the car. The car has round wheels, things that are round. That didn't go very far. And I'm thinking it didn't go very far because look, the carpet is not smooth like the ramp is. And the wheels kind of slow down on the carpet because of the friction on the carpet. Causes friction. Okay, let me get some balls back over here, and this one, and let's see our music toy, our round music toy. Looks like a cylinder. Let's watch to see if you can see it. Roll. Wow, did you see how far that rolled? That's pretty cool. So now we have this big truck. Let's try it on here. If I sit it up here, it's not going to go down the ramp. So I need to give it some force behind it or on top of it. Whoa, now it will go. See, that's how far it went. Let's try this one. And I'm worried about this one getting stuck at the bottom, but we'll see. It kind of got stuck, so it didn't go as far. And that's oh, this is a cool one. I like this one. This is not round on the outer edge. I mean, it kind of has this round, but it has all the spikes on it. So it's a round ball with spikes on it. So it's not probably going to go as fast as this one. Oh, look at. I didn't give that one any pressure. I just let go and let the gravity pull it down. This one, it needs some force. to make it, to put it in motion. That makes a fun sound. Now it worked because it was on an edge. Then it worked. Okay, so now, oh, and I have another bumpy ball. It's round and all the bumps are just adding texture to it. So it slows it down a little bit on the pink one, but the blue one rolled really fast. It was smaller and light. It rolled pretty fast and really far. So now you can add different textures to your board if you want to, and just to see if it changes how fast or how slow it goes. So like you can try a towel, put a towel on it. Let's see how fast our car will go. That didn't go very fast, because there's friction on here. This causes friction. Go slower. See, I smoothed it out. Did you see how I smoothed it out? It wasn't as bumpy. If I take this off, you see how far that car went? Let's see if it goes further with the towel off. I think it went a little further. It went faster, but still the carpet is slowing it down once it hits the carpet. So it didn't actually go, it didn't go slower. Oh yeah, and it goes a little farther too when it's just on there. But you can use different things. You can try tin foil, you can try a piece of paper towel, you know, a cloth. See, this cloth has a smoother side on this one, and it's bumpier on this side. So they might, it might make a difference. So I hope you have fun at home using cardboard or wood, and you can use boxes or baskets or anything that has a little height to it, and that you can put a piece of wood on or a piece of cardboard on, and you can build. That's part of engineering, and you can use different materials and practice and experiment and see what goes faster and what goes slower. It'll be lots of fun to do this at home with your family. And it's a great STEAM activity because it covers a lot of STEAM, science and technology and engineering and math. It's a fun activity. I hope you have a great week doing STEAM activities. Thank you. Have a great day.